Good day. Welcome to the first lecture for Geotechnics 254 for 2020. This lectures or this module will be presented as an online course, as you know by now, and I will give more details in the module guide once I received it back after approval. So Lecture 1, Portion 1. Charles Kellogg was a well-known soil scientist, and he has written or said, each soil has had its own history, like a river, a mountain, a forest, or any natural thing. Its present condition is due to the influences of many things and events of the past. So, lecture on Craig, part 1.1 and 1.2, about the origin of soils, Lecture 1, Portion 1. What is a soil? It is uncemented or weakly cemented accumulation of mineral particles formed by the weathering of rock. You can see the rock cycle on page 4 of the handbook, and the void spaces are filled either with water and or air. We get two types of soil, namely residual soil and transported soil. And transported soil is transported by water, wind, gravity, biological activity, and glaciers, as we saw in engineering geology in the previous term. The typical components of a soil profile: at the top you have a transported soil, then often you have a pebble marker, it's an accumulation of smallish rocks, which very typically distinguish the transition from transported soil to residual soil. You typically have rework residual soil and then the residual soil at the bottom. Residual soil, in other words, rock that has weathered in place. It has not been moved by any agent like the transported soils. The size and the shape of the soil particles are altered during transportation, and they are sorted in a specific size ranges. There's a little table at the bottom here showing the size ranges, but the following table makes it a little bit easier to understand. Boulders are rocks bigger than 200 millimeters. Cobbles is between 60 millimeter and 200 millimeters. Gravel bigger than 2 millimeters. Sand 0.06 millimeter to 2 millimeters. Silt is very fine, 0.002 millimeter to 0.06 millimeter. And clay is the fraction less than 0.002 millimeter. And soil are typically a combination of all the above mentioned particle sizes. The type of transportation and then the deposition thereafter influence the particle size distribution. For instance, if you have a glacier, the rock beneath the glacier is eroded either by friction or a freeze-thaw action. So the rock is really finely grinded by the movement of the glacier, and an example of that is the bicartilites that you get in the Karoo, which is very fine-grained material with larger particles inside it. So you get clay-sized, two boulder-sized particles carried at the base of the glacier, and as the ice melts, that deposition is known as till. So the bicartilite is an example of that found in South Africa. Water, for instance, as a transportation agent, rivers, normally in the warmer climates, and the material transported by water is known as alluvium. And then the composition, in other words, the particle size range, depend on the speed of water flow. If you have wind, it's typically in dry, sandy environments, and the material transported by wind is either known as loess or Aeolian sand. The Kalahari sands are typically Aeolian sands, and loess you typically get in the Sahara is a very fine, silty material. If gravity is the transporting agent, the material found on the side slopes or at the base of a slope is known as colluvium and is either talus or hill wash. So in pictures, the top left picture is alluvial soil. You see a wide range of rounded boulders. That's very typical of alluvial material, is that rounded material or rocks inside it. And as mentioned in engineering geology a few times, the whole of Stellenbosch is underlain by this alluvial rounded boulders material. And you can see from the size of the boulders here that we're talking about a fairly fast-flowing river. On the right-hand side, you have a Taylor slope, and if you look at the mountains around Cape Town area, especially around Stellenbosch, you will see this accumulation of fractured rocks. So they are angular, and that is known as Taylors. If it was just plain soil, it would have been called a hill wash. And then at the bottom, your typical Aeolian sand. I'm not sure where this picture was taken, but this you would get in the Namib Desert, in the Kalahari, and also in the Sahara. So this is the end of the first portion of the first lecture. See you next time.